Solving basic trig equations, part 2. So we want to solve this equation for theta. We want to find all the solutions, not just a few. We're finding exact solutions, so not using the calculator. And we're working in degrees. Well, let's follow our solving steps. The first step is to isolate the tangent theta in this equation. So I'll subtract the 1, and then I'll divide by the square root of 3. And then I know I'm about to draw a picture and I don't recognize that ratio over there. So I think I'm going to rationalize the denominator and see if that clears things up. I'm going to end up with tangent theta equals, obviously a negative. Let's see, I'll get 3 root 3 on the top, and then root 3 times root 3 is 3. And then the 3's cancel, and this looks much more familiar to me. So I'm getting tangent theta equals negative root 3. I've finished step A. One trig function, one variable, an equal sign, and a number. Step B involves drawing a good picture. I want to find all the solutions within one period of the tangent function. Well, the tangent function only has a period of pi, so I only even need to consider quadrants 1 and 2. Let's see, we have all students. Tangent is positive here. It is negative, though, in the second quadrant. So this must be a second quadrant angle. I'll go ahead and draw my picture. Here's the angle we're looking for. The tangent ratio. Let's see, of course, this doesn't really look like a ratio. It might help if I put a 1 underneath it, just for my own work here. Tangent gives opposite over adjacent. And of course, as soon as I write this down, I'm supposed to realize, oh, this is just one of those 30, 60, 90 triangles. The 60 is what's opposite the root 3. Now, a couple of comments to address. Could I have just used the tangent inverse function to find this angle? No, because tangent inverse only knows about angles between negative pi over 2 and pi over 2. Tangent inverse doesn't know anything about the second quadrant. So I really had to draw this picture. Second comment, are there other solutions? Is there another triangle I could draw within one full revolution? Well, of course, tangent is positive in the third quadrant, but it is negative here in the fourth quadrant. I mean, I could draw another symmetrical triangle over here and come up with a fourth quadrant angle that also solves this equation. I just don't have to. I'll deal with other solutions down here in part C. In part B, I just need to find solutions within one period, and we've done that now. Clearly, there's only one. It is that angle that we drew, and it is 120 degrees. Obviously, if the little angle is 60, then this big angle here, this second quadrant angle, is 120 degrees. Are we done? No, because we want all the answers. Well, you can get all the answers by simply adding on multiples of the period. Now, the period of the tangent function is pi, or since we're working in degrees, 180 degrees. So I would simply take my 120 that I found and add on multiples of 180 degrees. Here are all the solutions. Notice that this box includes that fourth quadrant angle we were talking about. If I simply added another 180 degrees to this, I'm going to be over here somewhere in the fourth quadrant. If I added another 180, I'll be back to here, and so on and so on. I could subtract 180s. It's the same thing. This one box covers all the solutions that exist for this equation. Thanks for watching.